So what I want to do in cleaning up something like this is get rid of that negative exponent. Now, let me ask you a quick question. What would you add to a negative 1/2 to make it to a 0? Positive 1/2. So my trick is, I'm going to multiply both the numerator and denominator by, let's do it in this color here. That should be 8 plus x to the positive 1/2 over 8 plus x to the positive 1/2. So effectively, I'm multiplying by 1, right? All right, now let's get rid of the extra x there. What I'm going to do is I'm going to distribute this term to both terms in the numerator. And in the denominator, I get a simplification of a different sort. When you multiply things with the same base, what happens with their exponents?
They get squared.
They add. So, for instance, if you had, say, x to the 4th times x to the 7th, you'd add these and get x to the 11th, right? All right, same thing's going to happen here. It's not written, but it's understood to be a 1 there. 1 plus 1/2, 1.5, or 3/2. So I'm just going to write 8 plus x to the 3/2 here. Now, this term here has to distribute itself to both terms here. So I have that times this, and that times this. So let me write it out at length. I've got 6 times 8 plus x to the 1/2 times 8 plus x to the 1/2 minus x times 8 plus x to the minus 1/2 times 8 plus x to the positive 1/2. And so I put it in different colors so hopefully you can kind of follow what's going on. This term just distributed itself to both of these terms. You okay with that? Yeah. All right. Now, kind of like the denominator, when you multiply things with the same base, you add their exponents. So we had 1 plus 1/2 is 1.5, or I called it 3/2. Let's do that same trick here in the numerator. 8 plus x to the 1/2 times 8 plus x to the 1/2. These are common denominator, or common bases, so I can add their exponents. What am I going to get for the exponent? 1. Minus x, 8 plus x. What am I going to get for the exponent here? 0. Ah, that's interesting. Now the nice thing about all this is that at least in the numerator, I don't have any more fractional exponents. I've cleaned it up pretty nicely. Now let's think what happens, what else can happen. Do I really need the 1 here? No. No. All right, so let's kind of get rid of that just because it's a distraction. And I'll get 6 times 8 is 48 plus 6x. What's something to the 0 power?
1.
1. So that's x times 1, or just x. And then I can subtract the terms here and end up with 6x minus x is 5x. 5x plus 48 over 8 plus x to the 3/2.
Why is it minus x in the numerator?
Because it came from this term right here. That's where the minus x came from. Now, if this was a 0, you're still stuck with the minus x. Anything else? Anything else on that one?
Looks good. Thank you.
You're welcome.
How did you get the exponent 0 in the second term?
When you multiply these terms together, you add their exponents. So minus 1/2 and a plus 1/2, that's what gave you the 0. And anything to the 0 power gives you 1. All right? Cool. Like and subscribe.